Morning student, now we are discuss exercise 4.1 class 11th NCRT, and in previous lecture we have discussed first 9 question and then start question number 10. And question number 10, let P of n 1 by 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 and so on up to 1 by 3n minus 1 into 3n plus 2 is equal to n by 6n plus 1. हमें by principle of mathematical induction से इसको prove करना है. Put first step n is equal to 1, then p of 1, this 1 put करेंगे, then up to 1 term this 1 by 10. left hand side is 1 by 10 is equal to RHS की बात करें, this RHS is 1 over 6 into 1 plus 4, this is equal to 1 by 10 is equal to 1 by 10. That means the value is true for n is equal to 1. Let us assume that the value is true for n is equal to k. तो n को हम k में रिप्लेस करेंगे, then p of k 1 over 1 into 5, 1 over 5 into 8, 1 over 8 into 11 and plus so on up to 1 by 3k minus 1 and 3k plus 2 is equal to k over 6k plus 4. And we shall prove that the value is true for n is equal to k plus 1. Then p of k plus 1, 1 by 2 into 5, 1 by 5 into 8 plus 1 by 8 into 11 plus and so on up to 1 by 3k minus 1, 3k plus 2 and then next term. इससे next term क्या होगी? There is 1 by 3 into k plus 1 minus 1 and there is 3 into k plus 1 plus 2. Then 1 by 3k plus 3 minus 1, 3k plus 2 and then this 3k and 3 plus 2, 5, 3k plus 5. Then next term k plus 1 other term is 1 by 3k plus 2 and 3k plus 5 is equal to, राइट हैंड साइड में क्या होगा, दिस k को रिप्लेस करेंगे, k plus 1, 6 into k plus 1 plus 4, this value is k plus 1 over 6k plus 10. Then right hand side is k plus 1 over 6k plus 10. This p of k plus 1. अब हम प्रूव करेंगे लेफ्ट हैंड साइड इज इक्वल टू राइट हैंड साइड, यूज करेंगे दिस p of k टर्म and then we know that this left hand side of this term 1 over 2 into 5 plus 1 by 5 into 8 plus 1 by 8 into 11 and plus so on up to 1 by 3k minus 1, 3k plus 2 and plus 1 by 3k plus 2 and 3k plus 5 and is equal to, this is the left hand side. We know that this complete value is p of k and p of k value is k over 6k plus 4, k upon 6k plus 4 plus 1 by 3k plus 2 and 3k plus 5, and then put this k over this 6k plus 2 is the common term, this 3k plus 2 plus 1 by 3k plus 2 and this 3k plus 5, and solve them by LCM. Taking LCM, is 3k plus 2, 3k plus 5 into 2 is the LCM. This complete divide to this k into 3k plus 5 plus this divided by this, and this term is 2. And then 3k square plus 5k plus 2 upon 2 into 3k plus 2 and 3k plus 5. We know that what is the right hand side, and right hand side is k plus 1 over 6k plus 10. हमें ये प्रूव करना था. Then हमें इस टर्म से ये टर्म निकाल के लेके आनी है. Then this factorize this numerator term, 3k square plus 3k plus 2k plus 2. This 3 2 is 6 and 3 plus 2 5. And then 2 into 3k plus 2 and 3k plus 5. And then factorize this. 3k is the common term and k plus 1, and 2 is the common term, then k plus 1 over 2 into 3k plus 2 and 3k plus 5. And then 3k plus 2 is a factor and k plus 1 is a factor, and this 2 into 3k plus 2 is a factor, 3k plus 5 is a factor. This cancel out to this k plus 1 over 3 2 is 6, 5 2 is 10, 6k plus 10 is equal to RHS. हम लेफ्ट हैंड साइड लेके चले थे और हमने राइट हैंड साइड निकाल ली. That means P of k plus 1 is also true. Whenever pk is true, then by the principle of mathematical induction, P of n is true for all natural number n. This question number 10, and then question number next देखते हैं. 11 question is the same question or same type of this question. Try yourself. And question number 12. Question number 12. P of n a plus a r plus a r square plus and so on a r raised to power n minus 1 is equal to a into r raised to power n minus 1 upon r minus 1. Is the formula of GP, but we can prove that the left hand side is equal to right hand side by the principle of mathematical induction. Let first we prove that n is equal to 1 is true for this value left hand side or right hand side. This P of 1 is first term, then first term is a, and this put r raised to power 1 minus 1 r minus 1, this cancel out to this, and a is equal to a. Then P of 1 is true for n is equal to 1. Then मैं सेकंड स्टेप से स्टार्ट करूंगा क्वेश्चन को. फर्स्ट स्टेप मैंने स्टेटमेंट से आपको बताया. देन नेक्स्ट टर्म, लेट अस assume that the value is true for n is equal to k. Then P of k, a plus ar plus ar square and plus so on, a r raised to power k minus 1, a r raised to power k minus 1 upon r minus 1. Then now we shall prove that the value is true for n is equal to k plus 1. Then P of k plus 1, ar square and plus so on up to plus ar raised to power k minus 1, and the next term is ar raised to power k, because ar raised to power k plus 1 minus 1, then ar raised to power k plus 1 minus 1, this cancel out to this ar raised to power k, and then right hand side is a into r raised to power k plus 1 minus 1 upon r minus 1. हमें प्रूव करना है this p of k plus 1 is this. P of k plus 1 हमने स्टेटमेंट लिखी, this is the left hand side and this right hand side. Use this p of k, this value is true for k plus 1 by using p of k. Left hand side and left hand side is a plus ar square and plus so on ar raised to power k minus 1 plus ar raised to power k. This value is complete value is a into r raised to power k minus 1 upon r minus 1, and this value is plus ar raised to power k. Then taking LCM of both the terms, this r minus 1 is the LCM, a into r raised to power k minus 1 plus ar raised to power k into r minus 1, this by taking LCM, and then a r raised to power k minus a plus a r raised to power k plus 1, this a r raised to power k into r power r की power 1 into r की power k, this complete addition a r raised to power k plus 1 a r raised to power k upon this r minus 1. This a r raised to power k is positive and this a r raised to power k is negative, this cancel out to this, and then this a r raised to power k plus 1 minus a upon r minus 1, and then this a is the common term, r raised to power k plus 1 minus 1 upon r minus 1 is RHS. Then left hand side is equal to right hand side. Then p of k plus 1 is true whenever pk is true. Then by the principle of mathematical induction, p of n is true for all natural numbers n. This value is true for n belongs to n. Then next 14 question number 14. P of n, this 1 plus 1 by 1 into 1 plus 1 by 2, this 13 and 14 both are the same question, and this 1 plus 1 by 3 into all term are multiplying. इससे पहले जो आपने टर्म की वो सारी टर्म समेशन में थी, प्लस में थी. This 1 plus 1 by n is equal to n plus 1. then this p of 1, अब ये 1 के लिए करेंगे, p of 1 plus 1, this value is 2, 1 plus 1 2, this 1 plus 1 is 2, then n is equal to 1, the value is 2 for n is equal to 1. Then next step, let us assume that the value is true for n is equal to k. Then p of k 1 plus 1 by 1 into 1 plus 1 by 2, 1 plus 1 by 3 and so on up to into 1 plus 1 by k is equal to k plus 1. And then now we shall prove that the value is true for n is equal to k plus 1. Then p of k plus 1, 1 plus 1 by 1 into 1 plus 1 by 2, 1 plus 1 by 3 and so on up to 1 plus 1 by k and 1 plus 1 by k plus 1 is equal to k plus 1, that means k plus 2. हमें प्रूव करना है this value is k plus 2. Then left hand side is 1 plus 1 by 1, 1 plus 1 by 2, 1 plus 1 by 3 and so on up to 1 plus 1 by k and this 1 plus 1 by k plus 1. And this value is p of k and p of k is k plus 1. This value is k plus 1 into this complete value is k plus 1 and then 1 plus 1 by k plus 1. Taking LCM of the second term, this k plus 1 over k plus 1 and then this value is k plus 1 into k plus 2 upon k plus 1 and this cancel out to this is equal to k plus 2 is equal to RHS. Therefore pk plus 1 is true. Whenever pk is true, then by the principle of mathematical induction the value is true for all n belongs to n. आप कर सकते हैं. And then up to 17 क्वेश्चन you can do. आप कर सकते हैं. मैं 17 क्वेश्चन आपको और करा रहा हूं. And then do yourself. All the question are same type and then do. This type question is 10th, this 1 into 3 into 1 by 3 into 5 or 10th question 1 by 2 into 5 all are completed. ये हम नहीं कर रहे. Then question number 15 करते हैं. Question number 15, p of n 1 square plus 3 square plus 5 square and plus so on up to plus 2n minus 1 square is equal to n into 2n minus 1 and 2n plus 1 over 3. P of 1 and P of 1 is 1 up to 1 term. This 1 square is 1. This put the value of 1, 2 minus 1, 1 and this 1 into 2 plus 1, 3 into 1 into 1, this 3 by 3 and 3 by 3 is 1. Then left hand side and right hand side both are equal. So for P of 1 P of 1 left hand side is equal to right hand side. This value is 2 for the value is 2 for n is equal to 1. Then let us assume that the value is true for n is equal to k. Then P of k 1 square plus 3 square plus 5 square and plus so on up to plus 2k minus 1 square is equal to k, 2k minus 1, 2k plus 1 upon 3. Now we shall prove that the value is true for n is equal to k plus 1. Then P of k plus 1 1 square plus 3 square plus 5 square and so on up to 2k minus 1 square, and the next term is 2k plus 1 square, this 2k minus 1, then put k plus 1 minus 1, then 2k plus 2 minus 1, then 2k plus 1, and the next term is 2k plus 1 whole square, and is equal to this value is k plus 1, and same thing this value is 2k plus 1, and this value is 2k plus 3, 2k plus 3 and divided by 3. Now this left hand side and this right hand side prove that the left hand side is equal to right hand side. Use P of k. Then left hand side 1 square plus 3 square plus 5 square and so on up to 2k minus 1 square and plus 2k plus 1 square. Use this value of P of k, and P of k is this k into 2k minus 1, this 2k plus 1 over 3 plus 2k plus 1 whole square, and then taking LCM is 3. This value 2k minus 1, 2k plus 1 and plus 3 into 2k plus 1 whole square. This complete term 2k plus 1 is the common term, 2k plus 1 is the common term, and then upon 3 ये भी आप निकाल सकते हैं. Then k into 2k minus 1 and this term is plus, and this complete term से आपने 3 को बाहर निकाल लिया. This 2k plus 1, 2k plus 1 एक बाहर निकाल लिया. Then 3 into 2k plus 1 and then 2k plus 1 over 3, and then this 2k square minus k, 2k square minus k plus 6k plus 3, and then 2k plus 1 by 3, this 2k square plus 5k plus 3. Then solve this quadratic 3 or 2, 5. This 2 plus 3. Then 2k square plus 2k plus 3k plus 3. 3 2 is 6, 3 plus 2 5. And then 2k plus 1 by 3. This 2k is common term. Then 2k, this k plus 1 plus 3 and this k plus 1. And then last term is 2k plus 1, then k plus 1 and this 2k plus 3 upon 3. is equal to right hand side, this k plus 1, 2k plus 1, 2k plus 3 over 3 is equal to RHS. Is equal to RHS. Then P of k plus 1 is 2. Whenever pk is 2, then P of n by principle of mathematical induction for all n belongs to n. Then you can do question number up to 17. You can solve all the questions.